Our last presentation of the day is Industrial Cybersecurity, Debunking the Myths and Staying Out of the News. First off, I have to say I love that title. It's great. So we have two presenters today. The first is Darren Gillis. Darren is an FSRA Electrical and Systems Integrator, ISA IEC 62443 Industrial Cybersecurity Fundamentalist Specialist. Now that's a title. He started his career as an industrial electrician in the oil and gas sector, specializing in wiring and commissioning control systems. More recently, he has moved into a controls and integration role based in Mills in BC, and joined ICI a year ago as a system integrator with a focus on industrial cybersecurity. Our next presenter will be Rob Wilson. Rob is an industrial network and cybersecurity specialist, ISA IEC 62443 cybersecurity expert. Rob's 35-year career has evolved from IT data network design and management to design and securing of industrial networks. With his early background in electronics technology and passion for all kinds of technology, Rob found it an easy choice to join the ICI team in 2019 as an industrial network and cybersecurity specialist. As British Columbia's only ISA IEC 62443 cybersecurity expert, he leads the company's ICS team and works with municipalities across BC to secure water and wastewater systems.
We on?
Yep.
Thank you, Chris. I'm just trying to share my screen here to get the slides up. Okay, can everybody see my screen? No? All right, trying to get going here, but I don't know if our screen is actually visible to you. Can you see our slides here?
Yep, your slides are visible.
Okay, thank you.
Thanks.
Thanks. Thank you, Chris, and welcome everybody. My name is Rob Wilson, and with me is Darren Gillis. Darren and I are part of the industrial cybersecurity team at Ici Electrical Engineering. I want to talk today about industrial cybersecurity. And you hear a lot about that today, and there's a lot of jargon around that, and there's a lot of myths as well. Our goal is to put a realistic lens to the jargon and debunk those myths. To do that, we'll be demonstrating a cyber attack against a water plant. In the process, we'll try to give you a view of what that attack looks like from the perspective of the operator and also of the attacker. So here's what we'll be covering in the next 40 minutes. First of all, Darren will talk a bit about the vulnerabilities in the OT environment, how we got here. We'll jump right into the demo, and the demo's in two parts. The first part I'll do, and I'll infiltrate a water plant from across the globe is the premise. Then we'll start talking about some of the 5 myths and why they're really not true. And then Darren will carry on the demo, and he'll take over where I left off, and he'll start interrupting the communications within the water plant, resulting in a reservoir overflowing and flooding a neighbor's yard. And last, and maybe the most important part of this presentation is, in the end, we're going to talk about the things that you can do in your plant to protect yourself against this kind of attack, and really to protect yourself from cybersecurity attacks in general. So Darren, why don't you tell us a little bit about ICI Electrical Engineering?
Thanks, Rob. So ICI Electrical Engineering, we specialize in engineering and securing industrial automation and control systems. Our three main specializations are engineering, as I said, in automation, control, and power systems, industrial cybersecurity, and we rely heavily on the ISA IEC 62443 set of standards in order to do that. We're heavily invested in them. And we do a lot of work in water and wastewater industry. We're based out of sunny Kamloops. And Rob, do you want to talk a bit about our partnerships?
Yeah, we partner with Schneider Electric. We're an Alliance certified partner. Also Phoenix Contact, we're a solution partner. We also work with Wonderware and Version Dog software. And again, we focus very strongly on the ISA IEC 62443 international industrial cybersecurity standards. We invest in that. You've already heard about us, so I don't need to say any more about that. Darren?
Excellent.
What
Absolutely.
about the vulnerabilities in OT systems?
Thanks, Rob. So a little bit of background, legacy systems were designed to remain air-gapped. When we were first designing our control systems, the rule was don't put them on the internet. Over the years, we've started to borrow a lot of stuff from IT, like modern protocols like Ethernet or TCP/IP. With that, there's been a greater demand to have information available to managers or production staff at their desks, on their phones, at home, wherever. With that, new opportunities for recipe management, production planning, that sort of stuff have come out of it. It's also really allowed us an unprecedented level of remote support that we can actually implement into these systems. You can have someone on the other side of the province or the other side of the country helping you out. The flip side of that is it's drastically increased the attack surface area of industrial automation control systems. It's given people a lot more ways to actually get access to these systems. So we're going to use a bit of jargon in this webinar. We're going to be using a lot of terms that might not quite make sense. So we're going to take a little bit of time to go over those terms. The first one would be Blue Keep. Then we're going to go over man in the middle. We're going to go over Kali Linux. And then we're going to go over the remote desktop protocol. So to start out, Bluekeep, CVE 2019-0708. So Bluekeep is a vulnerability in remote desktop services that allows an attacker to execute arbitrary code on a target system by sending specially crafted requests. What does that mean, Rob?
Well, arbitrary code, I see this definition often. A lot of the exploits, have the same kind of characteristic here. The arbitrary code is really a piece of software that we're going to try to land on a target machine, on a victim. And that piece of software will give us administrative control over that computer. The specially crafted packets or specially crafted requests is a series of data that we're going to send over the network that will trigger a bug in that target machine and cause it to run our arbitrary code.
Excellent. And as Rob said, that gives you full administrator access. You can do whatever you want at that point. Man in the middle. So what a man in the middle attack is when an attacker secretly intercepts and relays communications between two devices that believe they're actually talking directly with each other. So the attacker can intercept those communications. They can do some reconnaissance, start looking at the packets, start seeing what's in them. Okay, is this maybe a pump signal to turn on or to turn off? Or is it maybe a reservoir level? Once you've done that initial reconnaissance, you can actually start modifying that information to your own needs.
Yeah, and one of the things we'll talk about is Kali Linux. You may have heard of Linux, you probably have. Kali Linux, you might have heard of that. What Kali Linux is just a variation, a distribution of Linux. What makes it different is that it's bundled with about 600 different software programs that can help either a hacker or a legitimate penetration testing person to be able to infiltrate a network. They're free for everybody. They're free to download. They're well maintained. They work pretty well. And it's a bit scary because it's available for hackers, but it's a great tool for penetration testers.
You bet. And so the last one that we're going to go over is remote desktop protocol. So remote desktop protocol is a proprietary protocol built by Microsoft that allows remote connection and control of Windows-based computers. It's been packed into just about every version of Windows for decades now. It's always there. Usually it's run on a computer to allow remote support or IT people to get in there, something like that. That's typically where you'll find it. So we're going to turn it over to Rob. We're going to go over a little bit about a website called Showdown.io and what that's all about.
Hey, thanks, Darren. Yeah, Showdown.io, you may have heard it. It's a search engine, and somewhat like Google in that it goes out and it scans the internet constantly. And it's looking for any IP address that has any sort of connectivity open. It focuses on really the industrial and the Internet of Things type of hardware. So it'll see PCs, just regular PCs, but it'll also see PLCs, industrial gateways, drives, routers, webcams, just about everything. And what really makes us different and a little bit scary is that it probes a little bit further. It doesn't just find out the IP address of a device out there and what service it has, but it also will sometimes probe and tell you what version of software is running, even the password in some cases. So, this isn't specifically water treatment plants. You'll find lots of water treatment plants in there, but you'll also find power plants, buildings, cameras, everything under the sun. There's other sites, Binary Edge, Census, IVR Rocks, but Showdown is really the king as far as I can tell right now. So let me just give you a little glimpse of what Showdown looks like. So this is the Showdown landing page, and you can do some queries for free if you want. Just put in your plant's public IP address here and see what it knows about you. If you don't know that public IP address, just sit at your desk and type "what's my IP" in Google. It'll tell you. But what you can do here is search for things, and I've done a couple searches here. The first search is I've said, well, I want to see all of the Windows 7 machines that are running this remote desktop protocol in the United States. And as you can see, there's about 2,800 of them. And I know from a bit of research that Windows 7 running RDP is maybe exploitable through this Bluekeep exploit. What you'll see here is the information that comes back from Showdown. It doesn't just tell you how many are out there. It'll tell you the IP address of a potentially exploitable system. It'll also show you a screenshot of what the logon screen looks like. So you can tell from that this one is Windows 7 Professional. The next one, you can actually see the user ID. And again, it's Windows 7 Pro. Here's a couple of user IDs. And it goes on and on. Like I said, there's 2,800 of these. So that kind of information is very valuable. And the reason that Showdown exists is because it sells that information. You can get a little bit for free, but if you want some more details, you have to sign up for a subscription of $60, $100, $1,000 a month. So another example of a query, I've done here a query for Lantronix devices. Lantronix are often used in plants for communications. They convert from one type of communication to the other, from serial to IP. And I've searched here for all the ones in Ontario. And there's about 122 of these. And if you look at some of these, it says the first one, it tells me the IP address. First of all, I don't know why these are exposed to the internet when it's part of a plant. But anyway, this one is. This one shows a blank password. Maybe it doesn't, This one shows that you can press enter for setup. So it hasn't even been set up. If you connect to this device, you could set it up yourself. This is not a good thing. You get down here, have a look at this one. It actually tells you the password. Showdown has somehow dug in a little deeper in the query, and it's found out the password for this particular Lantronix devices. This is out in Ottawa. If that was the IP address of my plant, I'd be really concerned. So that's the kind of stuff that Showdown can show you, and it's a little bit scary. Showdown claims that they use this to help educate us so that we know when we're being exposed, but you can bet that hackers are using this to identify targets.
Right on. Thanks, Rob. So we're going to do a bit of a demo. And in this demo, we're going to be using this Bluekeep vulnerability to allow us to log on to the water treatment plant SCADA computer. Once we're logged on, we're going to start intercepting communications. We're going to do a little reconnaissance, and we're going to overflow that reservoir and try to flood a backyard. So we're not trying to teach hacking here or how to attack systems. The goal is to illustrate how simple it is, how little skill is needed, and how vulnerable these industrial automation control systems are when they're not properly secured. So what does this attack look like? So right now we've got an example of what a water treatment plant might look like. A lot of your municipalities might look similar. We've got a water treatment plant that's actually operating these two pumps, and we've got a remote reservoir that's giving us the level back. So we've got a reservoir PLC, a water treatment plant PLC. They're speaking to each other through this link, which is what we're going to actually exploit. And then the reservoir has its own local HMI or operator touchscreen interface. We've also got a Windows 7 SCADA machine, which is the Windows 7 could be in the public works yard, wherever it might be for you guys. And then we've got the attacker machine, which could be out there in the internet on the other side of the world. It doesn't matter. It could be anywhere. Okay, so how are we going to do this? The attacker machine, the first thing it's going to do is it's going to send that Bluekeep specially crafted packet with arbitrary code with this bottle of poison. It's going to dump that onto the Windows 7 SCADA machine because we found it on Showdown. We know it's vulnerable. Once we've done that, we're going to actually get that SCADA machine to call home back to our attacker machine and open the door on the firewall on the computer and say, hey, come on in, do what you need to do. Third, we're going to change the administrator password on that system. We're going to upload any tools we need, copy files, that sort of thing. Next, we're going to log on to the RDP. Now that we've changed that password, we're going to use that same avenue that your IT or support might use to get on that computer using our new administrator password. And finally, we're going to move this hacker toolbox, this Kali Linux, right onto the water treatment network. We're going to launch this as a VM that's actually run as a service on the SCADA machine. So to an untrained eye, it might look like nothing at all has changed. The SCADA machine is running just like it normally does. But in reality, the Kali machine is running in the background. So Rob, what does that look like?
All right, love to show you. So I'm going to bring up a couple of virtual machines here. And it's the ones that Darren's just been talking about. So let me just log on here and increase the font size. All right. So the first one is, actually, let me just minimize that, get rid of a little bit of stuff off my screen. All right, the first one is the SCADA machine that's in the water treatment plant. So you can see it's pretty pretty basic display, but this machine is in the water treatment plant. The other one over here is our Kali Linux machine. This is what the attacker is going to use. And like Darren said, this could be across the globe. It could be next door. It could be anywhere. It doesn't matter. It's out there on the internet. So in order to invoke this attack, remember we need some specially crafted packets and some arbitrary code. And it's really kind of hard to see. I've actually typed on the commands already in here just to make things a little quicker. And you can see that I'll show you that it's been exploited. But let me just show you the information that I had to type, just to give you an idea of how little information I had to provide in order to do this. So first of all, I had to say, well, this is the specially crafted packets that I want to use. And, I'm not a specially crafted packet expert or anything. I Googled this and it comes with Kali. They say, if you want to attack this way, use this one. I said, okay. Then for the payload, same thing. This is the arbitrary code that we talked about. Same thing. I Googled it. They said, hey, you want to do this? The best one is this one. So type it in. So I typed it in. The next thing I had to do is I had to identify the host that we want to attack. If this was a real, system, we would have found that on Showdown. We'd have the IP address. We'd punch it in here. The last thing we have to provide is our own IP address, and we'd know that, of course. And we need to provide that because we want this system to call home and to make the connection. Really, the last thing we have to type is exploit and tell the system to go out and do what it does, which is exploit the system. So if you look on this Kali Linux display, you can see that, yeah, here's where I set the payload. There's where I set, the remote host, the target. Here's where I type the exploit command. It's kind of hard to see on here, I know. But the important thing is after all these messages and it crunches around for a while, about 2 minutes later or even less, we get this session at the bottom. It says interpreter session 1 opened. So that is the key to say we now have a command line prompt that links us to that target machine. We now have administrator access to that machine. So at this point, I can start typing commands. I could type webcam list. and I can get a list of all the webcams. There's none on this one, but if there was, I could take a snapshot of what's being viewed on there. I could take a snapshot of what's being viewed on the screen. I can delete files, I can upload files, I can format the disk, I can do just about anything. What I am going to do, the first thing I'm going to do is I'm going to use a command called #dump. So what that does is it goes out and it lists all of the accounts that are present on this machine. And this is good information for me. I know there's an administrator account. I also know that by default on Windows 7, the administrator account is disabled. So I can't really use that right out of the box. But there's this other interesting one, SCADA user. So I think, okay, well, let me see what's going on there. So the stuff on the right, there's a whole bunch of stuff that looks like random characters. Not really random. What it is it's a form of encrypted password. And it's designed so that you cannot reverse encrypt it. So you cannot figure it out. However, Kelly to the rescue, there is a database. Well, let me just go back there and copy that. That's what I tended to do. I'll copy that set of characters and plug it in over here. And I'll use some software called Hashcat. And what it does, it looks through a database of about 1.2 billion passwords that it knows about, and it knows the hashes for. And so 2 seconds later, we see that the software has said the status of my request is that it has cracked the password. If you look up above, you'll see what the password actually is. In this case, it's the word password, except we've changed the letter S to 5, and we've changed the letter O to a 0. So, we could try the same thing on the admin, but I know because I set up the admin account. I used a complex password on the admin account. It's 14 random characters. It's not in the dictionary. There's no way it could be in the dictionary, and in fact, it's not. The thing is, if you're using passwords that are common names or numbers or something simple, it's going to be really easy to crack. This is a good reason why you should look at using a password manager so that you can use complex passwords built upon random, characters and numbers and symbols and stuff of 14, 15 characters long. So anyway, we know the password now to the SCADA user, but it's not an administrator. And we don't know the password to the administrator, and it's not active. So I'm going to deal with that issue first. So the first thing I'll do is I will type a command, and this is a command that comes with every Windows system. I'm now logged onto the Windows system pretty much as a super user. And I am going to say net user administrator, active, yes. So what that does, remember, it's the administrator account is disabled by default. Now it's enabled. And I don't know the password. So I'm going to change it to the phrase EOCP. So now I have a couple things. I can sign on as a SCADA user. I can sign on as administrator. I can actually just copy files from here if I want. That's an option for me. What I am going to do is I'm going to go grab just an ordinary Windows 10 machine that is just kicking around. It's just nothing special here. It's right out of the box, fresh install of Windows 10, no particular software. And I'm going to use the Rdp Client. This is what you would, if you're at home and you get a call in the middle of the night and you want to connect to your SCADA system if you're using RDP as the access method. This is the system, this is the way you would connect. And so I'm going to pretty much do the same thing as an operator or a support person would do in trying to connect to the plant. I'll use the password that I just created. I said the password should be EOCP. And so that's the password I'm going to try. We'll see if we get in here. And over here, you see that as that's chugging away, you see that the SCADA user is still logged on over here. I get a message about security. I don't care. And now I get a pop-up. Here I am across the globe, and it says, hey, if you're going to keep logging on to this machine, I'm going to have to boot off the SCADA user. I'm going to have to log off the operator. Do you want to do that? And of course, I want to do that. But now what happens over inside the water treatment plant is the operator, if there's an operator there, gets a message saying, hey, the admin guy is trying to log on here. Is that okay? And they could say yes or no, don't know. If they say nothing, then after 30 seconds, I would be logged on. So I'm just going to pretend that it timed out. And you see that the screen here in the water treatment plant goes to, state of being logged off. However, here I am across the globe, and I've got a remote connection now to that SCADA machine. So now I'm the administrator. I pretty much own that machine. I can do anything I want with it. What I will do is I'll install a bunch of software so that Darren can continue the attack. The software I'd install would be probably some IP scanning tools, do some reconnaissance. I would very likely install a version of Kali Linux running on a VM, tucked away where no one can see it. And at that point, we're kind of done with Kali Linux from this point of view, but we've moved Kali Linux right into the plant. So we've moved our attack into the plant, and now we can really start to do some damage. So I'm just going to bring these slides up again.
Excellent. Thanks, Rob.
So yeah, go ahead with the comments.
So we're going to talk about 5 common myths that we see all the time in industrial cybersecurity. Let's get into it. Myth number 1, we're safe because we don't connect to the internet. So the trend in industry is to provide remote access to OT networks for support and service. We're seeing a big uptick in that with COVID protocols, reduced manning and that sort of stuff. It really means that operators and other people need to be able to see what's going on with their plant. If maybe they can't visit all the time, it's a critical part of the infrastructure at this point. The other thing is your OT network might be connected to the internet without your knowledge. I've seen it at 3 in the morning. You're trying to troubleshoot a connection between 2 stations. You're moving Ethernet cables around. Sometimes the plant inadvertently gets on the IT network, and that might not be found for 3 years, something like that. And the system's on there. The other thing is being isolated from the internet doesn't fully protect you from hackers. Stuxnet is a good example. It's a very well-known industrial piece of malware. It was actually installed on Iranian nuclear facilities hardware because people dropped USB sticks with malware in a parking lot. The malware eventually ended up on the network, and they actually destroyed a bunch of centrifuges with that malware.
Scary stuff.
Yeah. Myth 2 is we're safe because our control systems are behind a firewall. If you look at the picture here, we've got a touchscreen, an operator panel with an antenna sticking out of it. So an equipment vendor installed remote access hardware. What that did is even if there were IT or OT protocols in place for that sort of thing, it bypassed all the firewalls, everything like that, and it just put the system, the control network on the internet. The other thing is, even if you do have a firewall, it requires care and feeding. It's not something you just set and forget. You always have to be looking at the firewall rules to make sure that that actually really reflects what's going on with your system today. That basically you're only allowing what needs to communicate through that firewall. Myth number 3, hackers don't understand control systems. The International DEF CON and Black Hat conferences provide workshops on how to hack industrial facilities and hardware. Industrial automation control system exploits are published as Metasploit exploit modules. So Metasploit is what Rob used to hack that system. That was that bottle of poison. You can get control systems exploits on there too. Another example is the Israel water system. Just this year, a couple times they've tried to get on there. They've tried to modify the chlorine levels on their water system. So hackers do understand control systems. Myth number 4 is our facility's not a target. So CSAR, the Cybersecurity and Infrastructure Security Agency, said in July, over recent months, cyber actors have demonstrated their continued willingness to conduct malicious cyber activity against critical infrastructure by exploiting internet accessible operational technology assets. They also said civilian infrastructure makes attractive targets for foreign powers. Now, another example is in 2016, there was a water system in the US that was compromised. Operators saw valves moving around and it didn't look quite right. So they caught them in the act and they shut it down. The funny thing is they say that they don't even think that the attackers knew they were actually attacking a water system. A lot of times, all it is that it shows up in that Showdown search and it's vulnerable. So hackers get on because they can see a target. They may not necessarily know that you're on the other end. Sometimes it's just not personal. And finally, myth number 5, our safety systems will protect us. We don't see a lot of safety PLCs and stuff in the wastewater world, but a lot of industries do use them. This example, Schneider Triconics safety controllers were controlling the H2S system on a petrochemical plant in Saudi Arabia. if they had been successful with this, they would have actually released H2S into the plant or caused an explosion. Luckily, they were programming and they faulted out the PLC, so they became aware of the attack that was happening. The crazy part is the attackers were on the IT network for 3 years before they were found out.
That is crazy. And I guess, we really are more vulnerable than we think. It's a cat and mouse game. It's the vulnerabilities are changing all the time and the risks are always there. So here's the second half of our attack, and here's where we left off. Now, I had installed a bunch of Kali Linux tools, and maybe some other IP scanning tools, on the SCADA computer. What Darren is going to do is carry this on. And first thing he's going to do is poison the comms between the water treatment plant and the reservoir. In doing that, he's going to cause all traffic between them to be instead routed through him. As he does that, he's got the opportunity to examine the traffic and get a better understanding of what's going on between those two PLCs. And also he has the opportunity to start changing that traffic and giving the water treatment plant PLC and the reservoir PLC completely different information. So let's just see what that looks like. It's an interesting show.
Thanks, Rob. Okay, so at this point now, you should be able to see my screen. What we've got on here is we've got a simplified demo. This is a demo, so things are moving a little faster than they would in a real plant, but it should look similar to what a lot of your plants look like. On the right, we've got our water treatment plant. As we're seeing from the SCADA, you've got your pump control over here. We've got our chlorine analyzer level and the set point. And then we've got the view of the SCADA where we can see the reservoir level coming up. Once it reaches a certain point, we should get our stop signal, which tells the water treatment plant pumps to stop, and the tank will drain back down until we get down to the start level, and the cycle continues. Probably pretty similar to a lot of places that you guys see. So right now, pumping just over 2,000 gallons a minute, and we've just received that stop signal. So over here, we've got the actual local operator interface for the reservoir. So we see a lot of the same info, the water treatment plant pumps, and we should see the pump kick on here, and there it goes. Now, down on the bottom, we've got our old friend Kali, that toolbox that we actually installed on the water treatment network. And we're going to see what we can do to actually exploit this and cause a problem here and see if we can flood a backyard. So the first thing I'm going to do is I'm going to load up our man-in-the-middle attack tool, which is called Rdp. Okay, and there we are. And so now with Rdp up and running, the first thing we're going to do is we're going to take a look around the network and we're going to see who's actually on our network. So we do a quick scan here. And we can see that we have 14. We know because we did our reconnaissance earlier that 14 is our reservoir. And 183 is our SCADA system, or sorry, our water treatment plant. So at this point, if we start a man-in-the-middle attack, nothing happens. And why is that? That's because we have redirected that traffic. That traffic's still going through Rdp, through our Kali Linux thing. We're doing reconnaissance. We want to see when does that pump signal turn on? When does it turn off? We want to see how does the SCADA system get that water level at the reservoir? And once we've done that and we've done our homework, we can stop the attack and we can apply a filter. So what the filter does is it takes all that info that we just got and it basically manipulates the data instead of just looking at it. So we'll load the filter, but we won't start the attack yet. Right now we can see what we're going to see is we're going to see this level on the SCADA system. It's going to go to 80%. We're going to get a stop signal. We're not going to get alarms. The SCADA system's going to be happy. Over here, we should see a completely different story. We should see both pumps come on from the water treatment plant, and we should see this reservoir start to overflow. So let's see what that looks like. We're going to start our attack once again. And we see 80% on our water treatment plant. It's calling for it to stop, but it says the water treatment plant's not pumping, so we should be okay, right? At the reservoir, the local screen is showing, no, that's not the case. We've got both pumps on. We've got over 3,000 gallons a minute coming into this system, and it's not stopping. So at this point, we're washing out whatever's around that reservoir. Maybe the reservoir is collapsing, that sort of thing. So when we stop the attack, things should go back to normal. We see the pumps turn off, and the system resumes operation. but the whole time we didn't get any alarms. So it raises questions, right? So what if this was a real system? What if we were messing around with chlorine levels? What if we have a critical pump for the operation that we tell that there's water there and you keep pumping, but there's no water there and it's running dry? Could do a lot of different things. So the next question is, how would we go about actually stopping this sort of attack before it starts?
Good question. And I think too, what this really demonstrates is that, there's a big difference between IT and OT. In all my years in information technology, I never once had to worry about, the consequence of flooding a backyard or overflowing a reservoir or burning out a motor or a pump. Very different consequences, very different risks, and we have different ways of treating it. So Darren, what are some of the ways that we can deal with this? Oops, sorry. How could we have prevented this?
Well, the first thing is, this system was running Windows 7. We see a lot of them today are actually running Windows 7. We could see on that on Showdown. Windows 7 isn't supported by Microsoft. So even if Windows 7 was patched, we wouldn't have been able to do this. But a lot of control systems, that they just don't get patched. So if it was updated to Windows 10, same thing. We wouldn't have been able to do that.
Yeah. And you remember how my jar of poison actually called home to establish that session. If we had have restricted the outbound traffic from that SCADA computer and not allowed it out to the internet, I wouldn't have been able to get that session and I wouldn't have been able to attack in that manner.
That's right. Yeah. And the other thing is that we could ensure firewall rules are set up so that only the traffic that's necessary for the plant to operate is actually able to move between different areas.
Yeah, and we used port forwarding. I see it used way too often. Port forwarding, typically the way it's implemented, it says you want to talk to RDP in this case, just jump right over the firewall rules and go straight to the SCADA server. Don't bother checking with the firewall. Not a good idea at all. There's better architectures for remote support. If you look at the ISA IEC 62443 standards, they got some great network security models.
You bet. And so the other thing that could have been done, maybe that RDP server was started and running because an IT person needed to get on there one time, but maybe you use Splashtop or TeamViewer typically. You need to get on that computer and have a look around for services that are running that really don't need to be. A lot of those can be doors that can just, they can be open for attackers to come in through.
Yeah. And you saw how we cracked that non-trivial password, password with the 5s and the 0. The days behind us that we should be doing using trivial passwords. Use complex passwords. Get yourself a password manager. They're easy to use once you get used to them, and they'll keep your system safe or safer.
Absolutely. And the last thing that we probably could have done, there's probably more, but one of the other things was use an intrusion detection system on the network or on the SCADA PC. That might not have stopped the attack, but we would have known at probably the reconnaissance stage or the stage where we're trying to get that jar of poison on that system that, hey, there's a problem, and we would have been able to shut it down.
Yeah, we would find out in 3 minutes rather than 3 years that someone's been on our network.
Yeah.
So those are some really good points for this particular attack. And, almost any one of these would have helped out and maybe prevented the attack. But, in a more broad sense, there's other stuff that we can do.
Yeah. So one of the main things is, again, we keep talking about passwords. It's using those non-trivial passwords and changing the default passwords on your control system hardware. We see this all the time. It only takes 30 seconds to Google. If it's that easy for us to Google, it's as easy for hackers. You may as well not have a password on there.
Yeah, and patch your systems. IT's very good at this these days, most shops. OT maybe not as good. But there's different risks associated in a plant than there are in a data center. So patching PLCs and VFDs, very important, but also there's different risks. Can you tell us about that, Darren?
Yeah, you bet. So if you update a PLC, if you update the firmware on it, sometimes it stops talking to things, even software, that sort of thing. You really want to have a control systems expert doing that work. You don't want to end up with a plant that's not running just because you tried to patch a PLC and it stopped talking to different things.
Yeah. And, physical security used to be, the main thing for securing a plant. Now with cybersecurity and, network connected plants, there's a lot more to it. But that doesn't mean that the physical security measures are to be forgotten. There's always sneaker net. Someone can get physical access to your network. They have access to your plant.
Absolutely. Firewalls, we've already talked about. Make sure those rules are up to date.
Yep.
A key switch on a PLC, run versus program. A lot of PLCs, they'll have the ability to run or have remote program, that sort of thing. Keep them in run if they're running. Keeps those remote programmers from being able to program, but more importantly, it keeps the attacker from being able to program. You can throw it back in program if you know someone's on the other end and they have to program.
Yeah. And we talked about remote access. Avoid the simple port forwarding to get to your services. There's way better approaches. Find a secure by design approach. So these are these are a handful of maybe easy ones to implement, or ones that we would maybe put up front. But they're really kind of short-term solutions. In the long term, what would you recommend, Darren?
Well, really, this is kind of low-hanging fruit, but more importantly, it's to have a cybersecurity management program system. Basically, that makes sure that you're addressing the parts of your plant that are the most critical, the most important to run on a day-to-day basis, that they have the proper measures in place to make sure that that remains secure. The other thing that CSMS does for you is it makes sure that you have some sort of avenue to make sure things stay up to date and stay as secure as possible. A lot of times what we see is people do a one-shot deal. They think they're secure, but over time we know plants change, hardware changes, vulnerabilities change. Really having a fully comprehensive cybersecurity management system is the only way to make sure that going forward your plant is as secure as possible.
Yeah. And usually the first step in doing that is doing an industrial cybersecurity risk assessment. That process, part of the cybersecurity management system, really helps you to focus on what areas of the plant need your attention most. Where should you put your investment in money and in effort to best secure your systems?
Absolutely.
So if you'd like more information, we encourage you to visit our website, icieng.com/EOCP2020. And if you have any questions about the presentation or any comments, Darren and I would both welcome an email or a call. Love to help you out if we can, and love to answer any questions.
Absolutely. And one last thing, we've got our principal, Sean Bouchard, and Bill McMillan are doing a presentation tomorrow, and that's in the wastewater stream, and they'll talk a lot more about what a cybersecurity management system is, and some more details about how that all works. So we'd encourage anyone that has the opportunity to check that out as well.
Yeah, right on. And with that, if anyone has any questions, we'd be happy to attempt to answer them.
I see that we don't have any questions up on the screen right now, but I have a question for you, gentlemen. With cybersecurity measures, is that something you're seeing more of in commissioning stages in water and wastewater?
I would say, I don't want to, I would say yes, but what we're seeing now is that the willingness to invest in cybersecurity typically follows an exploit or an exploit of a neighbor. And what we're trying to do here is to let people know that this is happening to everybody. I mean, there's communities throughout BC that have been hacked, and it's going to continue until everybody kind of steps up their game and kind of gets a little bit ahead of the people that are hacking them. So we do see it happening. We've got a couple of jobs going on now that we're taking a serious crack at securing a plant. I'd like to see more of it, though. I would tell you that.
Yeah.
We've had a couple questions come in here. So one is, I'm wondering about the passwords. What is the best route to get the best password? So maybe if you can expand on the password managers.
Sure. Yeah. So I can probably field that one. So basically, you know, when we exploited those passwords, that's taking passwords that have either ended up on leaked password lists, or it'll actually search through every word on Wikipedia. They'll take those kind of things, and that's what you're cross-referencing. So that's what that hash turns into, is actually a cross-reference toward those sort of things. If you're using something like LastPass, Keeper, and, you know, a password manager of your choosing, typically you're using one password to access your password database, and you don't even remember the rest of your passwords. All it is a jumble of letters, numbers, symbols, and really that's what we're talking about when we're saying use a password manager. Have the password manager do the dirty work for you, give you that mixed up password, and use that in place of something that you have to remember or something you have to write down.
All right. Thank you very much for your presentation. That was very technical, and I enjoyed that. Hopefully, everybody out there in the audience enjoyed that as well. So, thank you very much for your presentation, and this concludes the day one for our water stream. I hope everybody at home had a good time today and is ready to join us tomorrow. So be sure to fill out your surveys today, and we'll see everybody tomorrow. Thank you very much.